Hello Year 9. Today what we're learning is about significant figures. So no matter how accurate measuring instruments are, a quantity such as length cannot be measured exactly. Any measurement is only an approximation. A significant figure is a number that we believe to be correct within some specific or implied limit of error. Now there are 4 rules on determining how many significant figures are in a number. The first rule is that all non-zero digits are significant. The second rule is that when we're starting from the left, the first significant figure is the first non-zero digit. So in the number 0.003250, the 3 is the first significant figure. In 865,000, the 8 is the first significant figure. In 7.008, the 7 is the first significant figure. Now the third rule is that any zeros between the 2 significant digits are significant. So if we go back up and look at our last example of 7.008, these 2 zeros in between our 7 and our 8 are significant. Then we have that all final zeros or trailing zeros in the decimal portion only are significant. So that means that in this question here, our 0 at the end is significant. However, these zeros here in 865,000 is not significant. Now, the method for counting significant figures is that every figure between the first and the last significant figure is significant. So now we want to have a go at saying how many significant figures are in each of the following numbers. So we start with our first non-zero digit. So in 316 million, our significant figures are our 3, our 1 and our 6. So this number has 3 significant figures. In our next number, 315,000, our 3, our 1 and our 5 are significant. So again, this only has 3 significant figures. In C, 42,007, our 4 and our 2 and our 7 are non-zero digits, and the zeros in between our non-zero digits are also significant. So this number has 5 significant figures. In D, our 31.005, our 3, 1 and 5 are non-zero digits, and the zeros in between are also significant. So we have 5 significant figures. And in E, 0.00013050, our first significant figure is this 1, 3 and 5 are our non-zero digits. This 0 is in between and this 0 is trailing. So those 5 digits are all significant. Now, I want you to pause the video and have a go at working out how many significant figures are in each of the following numbers for the UDO. Okay, so you should have answered that there are 2 significant figures in 21, which is our 2 and our 1. In our 6.40, our 6 and 4 are non-zero digits, and this 0 trails the decimal point, so it is significant. So there is 3 significant figures. In 0.00567, the 5, 6 and 7 are all non-zero digits and are all significant, so there are 3 significant figures. In D, our 250.043, our 2, our 5, our 4 and 3 are all non-zero digits, and these zeros are in between our non-zero digits, so they are all significant, so the answer is 6 there. In E, 0.010003, our 1 and our 3 are non-zero digits, and the zeros in between are also significant. So there is 5 significant figures there. Now, to approximate a certain number of significant figures, we write the number that contains only the required number of significant figures and is closest in value to the given number. So we can round to a certain number of significant figures if we are told to in a question. You need to remember that we round up if the next digit is greater than or equal to 5. Let's have a look at some examples. we want to round these numbers to one significant figure. So in 8,170, our first significant figure is the 8. We then want to look at the number after that first significant figure, and if it is greater or equal to 5, we would round the 8 up. But because 1 is less than 5, we are going to write that our answer is 8,000. So we just replace all the other digits by zeros. In C, our first non-zero digit is the 3. Now we have to look at the digit after the 3, which is a 5. Because this 5 is greater than or equal to 5, we have to round up to make the 3 a 4, and then we make all the other digits 0, so that our answer is 40,000. For C, we have 14,580. We have to look at our first non-zero digit, which is the 1, and then our digit behind it is a 4. Now, because 4 is less than 1, we do not round up, we round down, so our answer will just be 1, and then all the other digits become zeros to get our answer of 10,000. For D, we have 0.035. We need to look at our first non-zero digit is a 3. The digit behind it is a 5. So that 5 is going to round up our 3 to become a 4. And we have to write in anything that's before it. So our 0.04. In E, we're rounding to one significant figure still, so we have our 6. We look at our digit behind it, which is a 7. Now, because our 7 is greater than or equal to 5, we have to round up our 6 so that it becomes a 7, and we have to write in any digits behind it as well. Pause this video and have a go at the you-do questions on your worksheet. Okay, so our answers for our you-do questions. For 3.17, our 3 is our first non-zero digit. The 1 behind it is not greater than or equal to 5, so our answer just becomes 3.00. In B, we have 84.9. Our first non-zero digit is the 8. Oops. The 4 behind it is not greater than or equal to 5, so it just becomes a 0. So we'll have 80.0, which we can just write as 80. We can just write this 3.00 as 3. In 25.8, we have our first non-zero digit is a 2. The number behind it is a 5, which is greater than or equal to 5, so you have to round it up. So this becomes 30, and we make every other digit a 0, and so it will be 30.0, which is just 30. In 412, our first non-zero digit is the 4. The 1 behind it does not round the 4 up because it's not greater than or equal to 5. So our number just becomes 400. And lucky last in E, we have 0.0098. The 9 is our first non-zero digit. The 8 behind it is greater than 5, so it has to round the 9 up to be 10. So it will be equal to 0.0100, which we can just write it as 0.01. Now looking at question 2, we want to round these numbers to two significant figures. So we want two numbers that are significant. So we have our 8.4. Our 5 after it is not significant, but we need to see whether the 5 will help us round up the 4, which in this case it will. So we'll have our answer as 8.5. First two significant digits are 2.1. The 1 behind it does not round it up, so our answer will just be 2.1. In 655, our first two significant digits are the 6 and the 5. The 5 behind it is greater than or equal to 5, so it will round up our 5 in front of it to become 660. In 76,399, our 7 and our 6 are first two significant figures. The 3 behind it is not 5 or larger, so it does not round up. So we'll have 76,000 as our answer as we make our other 3 digits zeros. And lucky last, we have our 76 as our 0.005, so our 76 is our first two significant figures. The 0 behind it does not round up, so our answer will just be 76.000, which we can just write as 76. Pause the video and have a go at the you do section of question 2. Okay, so you should have answered it as the first two non-zero digits, the 8 and the 2. The 8 behind it does in fact round the 2 in front of it up. So our answer will be 0.083. We have 2.75, the 2 and the 7 are significant. The 5 behind it is 5 or larger, so it will round up the 7. So our answer will be 2.80, which we can just write as 2.8. C, we have 7.36894. The 7 and the 3 are the first non-zero digits that are significant. The 6 behind it is greater than or equal to 5, so it will round the 3 up to get 7.4000, which we can just write as 7.4. For D, we have 0.00716. Our first two non-zero digits are our 7 and our 1. The 6 behind it is greater than or equal to 5, so it will round the 1 up, so that our answer will be 0.00720, which we can just write as 0.0072. And in E, our first two digits that are significant are the 3 and the 0. This 6 behind it rounds up our 0 to become a 1 because 6 is greater than or equal to 5. So we'll have 3, 1, and we make our other two digits 0. Lucky last, we're going to have a look at rounding these numbers to 3 significant figures now. So we want the first 3 digits and the first digits are zeros, like so. So then we just want to look at the number after our first 3 digits, and if it is 5 or larger, which these numbers are, it means that we are going to round up the digit at the end. So our first one, we should get the answer of 1. We have to add 1 to the 9, so it becomes, instead of becoming 1.09, it becomes 1.10. The next one, the 8 rounds up the 4, so it will be equal to 695.0, which is just 695. We then have 35.085. The 8 rounds the 0 up to become a 1, so it will be 35.100, which is just 35.1. For D, we have 0.0815. The 4 does not round it up, so it'll be 0.815, and we make that 4 a 0, which is just 0. Oops, there's meant to be a 0 out the front of that. So it'll be 0.08150, which is just 0.0815. E, we have 9.0. Oh, that 5 rounds up the 9 to be at 10, so it'll be 9.1000. So we can just write this as 9.1. Alrighty, pause the video and have a go at the next 5 questions. Okay, so again, we want to look at the first 3 digits our first non-zero digit and then the 2 digits after that. We also want to look at the digit after our 3rd digit to see whether it is 5 or more. These ones are. Now, because they're 5 or more, it means we have to round the number at the end up by 1. So our first answer, you should have got 5.72. The next one, you should have got 0.724. You should have then got 456,000. Then you should have got 0.04. We have to round up, so 0.1. And lucky last, you should have got 14.66. Alrighty, so they are the answers. So make sure you copy them down and then have a go at the worksheet and your booklet.